Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to move on to the next chapter, and that is application of derivatives. Today we'll be talking about application of derivatives from NCERT class 12th. A very important chapter from the point of view of all examinations that you'll be appearing for. Questions are asked from this particular chapter throughout. In any examination you pick up, lots and lots of questions are asked from this particular chapter over here. This is exercise number 6.1 that we'll be discussing over here, and let's see what does the first question say to us. The question says, find the rate of change of the area of a circle with respect to its radius r when r equals 3 centimeter, r equals 4 centimeter. That's what the question says. Now, rate of change, what do you mean by rate of change? Rate of change is not a difficult concept, it's a simple concept. When we talk about any function, let us say y is a function of x. So, dy by dx is actually rate of change of y with respect to x. This represents rate of change of y with respect to x. Mind you, we need to be careful about these variables. Many times the function can be given in this particular form, and further the condition may be given in such a manner that you are given maybe rate of change of y with respect to some other variable time t or some other variable z for that matter. In that case, what you will be interested in, rate of change of y with respect to t is what you will be interested in, right? This is what you'll be interested in. And how will you find that? This is pretty simple to find. You will have to do dy by dx times dx by dt, and this is a simple idea of chain rule, right? For differentiation, this is a simple idea of chain rule. Dy by dx is nothing but f prime x. This is what you call that, right? F prime x times dx by dt is what I have over here, right? Those are the ideas. So be very careful when you want to view that rate of change with respect to what and rate of change of what with respect to what. Those are two important things. Rate of change of y with respect to x is represented by this symbol over here, right? Continuing further, let's talk about this particular question and what do we do in this question. Let's talk about that. We are supposed to find the rate of change of area of a circle with respect to its radius. Now, some things are assumed that you will be aware of certain things. That is, you should be aware of what is area of circle in terms of radius maybe, right? So, we are aware of area of circle will be equal to pi r square, where r is the radius of circle, right? This is the area of the circle having radius r, okay? Rate of change of area with respect to its radius is being asked. So what have we asked is dA by dr is being asked. Rate of change of area with respect to r is being asked. Now let's find dA by dr by differentiating that a. A equals pi r square, which implies dA by dr. Okay, this is one variable, this is other variable. Basically this is dependent, this is independent, right? So dA by dr will be equal to pi times r square. The derivative of r square is 2r, which is pretty simple, right? But in the first part, this is okay, rate of change of radius. In the first part, since you may observe that you require the value of radius to find the exact rate of change, right? The rate of change depends on the radius, right? So you're given that in the first part r equals 3 centimeter, okay? Now, when you encounter units, let me remind you one special thing about units. In physics and chemistry, you have to be very, very careful with units, right? And there are a lot of different kinds of units used in physics and chemistry questions. But when you talk about maths, they generally use one particular unit for length, one particular unit for mass, and one particular unit for time in that case, right? In any case. But be very careful. They may, in certain cases, use different units for length. They may use centimeters as well as meters, right? So what are we supposed to do? We are only supposed to take care of one small thing. And what is that small thing? We have to be consistent in units. What do you mean by consistent? Consistent simply means that whatever units you use for one particular length, one particular location of length, you should use the same unit throughout for length in that question, right? Now, when you see this question, it is a pretty simple one. The radius is given in terms of, let us say, centimeter. This is 3 centimeter. So, the rate of change of area will also comes in terms of maybe centimeter, something in terms of centimeter, right? So, area is actually centimeter square, radius is centimeter, right? This is what you have. Centimeter square per centimeter is the kind of thing that will be getting, right? That's what you'll be getting. So, be consistent, and that will solve all your problems without affecting anything, right? In mathematics, be consistent with units. That's very important. You don't have to worry about interconversion too much. But in case the person has used different units for length at 2 locations in the same question, you have to be careful. Otherwise, generally, mathematics people do not worry with units, right? Take care of that and you're good to go. So let's continue further. R is given 3 centimeter. Therefore, dA by dr, the magnitude, what will that be? That is equal to pi times 2 times 3, which is 6 pi. And what will be the unit? Unit, since you are consistent in length, area is actually, so unit of area and unit of dA, exactly same. Don't worry about that too much. This is centimeter square, this is centimeter. So, this should be centimeter square per centimeter. Oh. But you remember something else. What is that? These will get cancelled and you can actually write this. You can actually write this as this also, but this is the version that we'll be getting. Okay, so 6 pi centimeter square per centimeter, this is the first part for us when radius is 3 centimeter. What about the case when radius is 4 centimeter? Let's take a look at that second one over here, right? We have done all the calculations over there on the right hand side, and let's do this. Let's solve the second part over here on the left hand side. This is part A and this here will be part B. Let's take a look at part B now. So part B, in part B, the radius is given as 4 centimeter. Therefore, dA by dr will be equal to what? dA by dr will be pi times 2 into 4, which is 8 pi centimeter square per centimeter. This is what I'll get, and that is my final answer for this question over here. Let's move on to the next one after this. The next one says the volume of a cube is increasing at the rate of 8 centimeter cube per second. Okay. How fast is the surface area increasing when the length of an edge is 12 centimeter? So the person is talking about two very different things related to a cube. For a cube looks something like this. This is what a cube looks like. And the back edge would be behind, right? This is what a cube looks like. All the edges are exactly same length. And the volume of a cube is increasing. So volume of a cube is increasing in terms at the rate of 8 centimeter cube per second. Now when seconds are involved, you know that you are talking about time, right? So with respect to volume, it is given volume of the cube is simply a power 3, and you are given that dV by dt, rate of change of volume with respect to time, is 8. Oh, why not write centimeter cube per second? We can write that. But remember, the most important thing about units in mathematics is you have to be consistent, right? That's the only thing that you need to take care of. If there is any other unit used somewhere, for example, length is measured in centimeter here also it is measured in centimeter. So answer will also be in centimeter. We are not supposed to worry too much about anything, right? How fast is the surface area increasing when the length of an edge is this? So surface area, let us denote surface area by S. Surface area is equal to, there are 6 faces of each having area a square. So this is 6a square, right? Surface area. For those of you who don't remember surface area, what is surface area? Look, imagine the cube in front of you, and this is the area of this surface. Similarly of this surface and this surface. Then you'll have 3 more surfaces, one opposite this, one opposite this, and one at the bottom, right? So you'll have a total of 6 surfaces and each having area a square. The total surface area will be 6a square. And what are we asked? How fast is the surface area increasing? ds by dt is being asked. Fast, right? This is being asked. Okay, and how do we deal with this one? We are given certain things. And what's the link between these two? The link is that A. You remember this? You see this, right? So volume is a cube. Let's use that. V is equal to a power 3, which gives me dV by dt. Okay, dV by dt, we are supposed to use that, and that is equal to differentiating 3a square times dA by dt. What have we done? We have applied the chain rule, right? There will be something called dA by dt, right? And what about given S equals 6a square? This gives me ds by dt is equal to 12a dA by dt. Okay, and you can observe the common link is this. The common link is this in this statement and this statement. From 1 and 2, can you write ds by dt very easily? The expression for ds by dt will not be very difficult. ds by dt will be equal to what? This is 12a times dA by dt. Now what is dA by dt? This is dV by dt upon 3a square. 1 over 3a square times dV by dt. Using 1 and 2. This is what I get. And now I can substitute the values very easily. Since it is given that when the edge of a length is 12 centimeter, this is also given to me, right? A equals 12 centimeter. At that point, you are supposed to find this. Let's talk about this one. This expression will be equal to 12 by 3 is 4. A upon a square is a dV by dt. Therefore, ds by dt, let's substitute the values. 4 is okay. A is 12 and dV by dt is 8. Okay. What will be the final unit? You can guess the final unit by writing the units here only, or you can simply guess the unit with the help of this. This is in centimeter square and this is in seconds. So centimeter square per second will be the unit of this expression. What's that? This is 3. This is equal to 8 by 3 centimeter square per second, and you can leave the answer at this stage. That's the complete solution for this question over here. Let's move on to the next one after this. The third question says, the radius of a circle is increasing uniformly at the rate of 3 centimeter per second. So, we are given that radius of a circle is increasing at some rate with respect to time. We are talking about with respect to time, right? Find the rate at which the area of the circle is increasing when the radius is 10 centimeter. Okay, we are given a circle, right? And in case of a circle, this is the radius, right? And you are given that dr by dt is equal to 3 centimeter per second. Consistency is important. Units of length should be centimeters only, and unit of time, if anywhere else it is given in terms of seconds, it is okay. If you are using if it is given a different unit of time is given at any location, you'll have to worry. But otherwise, it is okay, right? So this is one information. Find the rate at which the area of the circle is increasing. Area is something that I am aware of. This is pi r square. And it is asked rate of change of area. Find the rate at which the area of the circle is increasing when radius is 10 centimeter. That's the information that is given. Okay. And this is given. This is asked with the help of this. We'll use this A equals pi r square to solve our question. dA by dt will be simply equal to what? Do you observe that? We'll have to differentiate with respect to time. Therefore, we'll apply the chain rule. This is 2 pi r. Pi times 2r, and derivative of r with respect to time will come over here extra. That's the formula. Now we can substitute the values. A by dt will be equal to 2 pi times r is 10 and dr by dt is 3. This is what we have. What will be the units? Units can be measured by writing the units over here, or you can observe the units directly from here. Area is in centimeter square, this is in seconds. So this becomes centimeter square per seconds. What is this? 60 pi centimeter square per second is my answer over here. That's my final answer for this question, as you can see clearly. Let's move on to the next one after this. The fourth question. An edge of a variable cube is increasing at the rate of 3 centimeter cube per second. You're given a variable cube. How fast is the volume of the cube increasing when the edge is 10 centimeter long? A relatively simple question. The second question was slightly more difficult, but this is relatively simple. We are given a cube. A variable cube, yes. This is a cube, and this is, let us say, the hidden edges, right? These are the hidden edges. Okay, and edge of a cube is increasing at the rate of 3 centimeter cube per second. Let's call this A, the edge. So dA by dt is given to be 3 centimeter per second. Okay. Next, how fast is the volume of the cube increasing? Volume of the cube is simply A power 3, and you're asked dV by dt is equal to question mark. When the edge is 10 centimeter long, when A equals 10 centimeter. Now centimeter, so we have consistency in units, right? We are not supposed to worry about anything too much, about the units too much. Let's focus on solving the question now. V equals A power 3. So dV by dt will be equal to what? dV by dt will be 3a square, and applying the chain rule, this will be dA by dt. This is what you'll get. Is that okay? Yes. Pretty simple. Therefore, now let's substitute the values. dV by dt is equal to 3 times a square. What is a? A is 10. 10 square times dA by dt is also 3. So this is 900. And what will be the unit? This is centimeter. Length is in centimeters, so this becomes centimeter cube. This is in second. Centimeter cube per second is my answer for this question over here. That's the fourth question for us. Let's move on to the next one over here. The fifth question. What does the question say? A stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeter per second. That's the question. Let's see. Stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeter per second. Okay. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? Now waves are moving at the rate of 5 centimeter per second. What does that imply? Let's take a look at the lake from the top. From the top, if let's say this is a lake, this is some random shape of lake, and you drop a stone over here, so waves will be formed, circular waves will be formed, and they will be moving out. They will be moving out, right? So this distance from the center, is actually the radius, and what is given is stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeter per second. Wave is moving, therefore this radius is increasing at that rate is given. dr by dt is given to be 5 centimeter per second. That's the important thing to observe over here. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? Now enclosed area will be area of circle, which is pi r square. Not very difficult. So the next thing that is asked is dA by dt. And once you have noted this information properly, drawn the diagram as well, you understood the complete problem, and it is very easy to tackle this problem now. A is pi r square. So dA by dt, mind you, we are talking about rate of change with respect to time, is equal to pi times 2r times, applying the chain rule, this is dr by dt, right? Therefore, now let's substitute the values. dA by dt becomes equal to 2 pi times r is 8. dr by dt is 5. Okay, you have not written the units. Doesn't make a difference, right? We are not dealing with physics and chemistry. We are dealing with maths over here. And this length is measured in centimeter throughout. Time is measured in second throughout. So area is measured in centimeter square. This is second. So this becomes centimeter square per second. This is 80 pi centimeter square per second. And yes, this is the final answer for this question, as you can see behind me. Let's move on to the next one after this. The sixth question says, the radius of a circle is increasing at the rate of 0.7 centimeter per second. What is the rate of increase of its circumference? Let's talk about this. Radius of a circle. So once again, we'll be drawing a circle first. This is what a circle looks like. And radius of a circle. Let's talk about the radius. This is the radius. It's increasing at the rate 0.7 centimeter per second. What is the rate of increase of its circumference? What is circumference? Circumference of a circle is represented by c, let us see, and this is perimeter of circle, circumference of circle is 2 pi r. This is what we have. dr by dt, what is the rate of change of its circumference? What implies that we are asked dc upon dt. Oh, we are not given the radius. That means that radius will not be required, right? We have been given radius whenever questions were based on area, but in case of this particular case, when we talk about circumference, the radius is not given. It may not be required, right? Let's take a look at this. So C is equal to 2 pi r, we are aware of this, which gives me dc over dt is 2 pi, and what's the derivative of r? This, with respect to time. This is what you have. And therefore, now we can substitute the values. dc by dt will be 2 pi. You may observe we only read dr by dt, which is 0.7. And what will be the units? Circumference is measured in, once again, it is length. So it is centimeter per second. That's the unit. Right? What is this? This is 1.4 pi centimeter per second. One more thing can be done over here. If you take pi as 22 by 7, it is not given. We can leave the answer at this stage as well. But if you take pi as 22 by 7, you can maybe cancel a few things over here. And what you will get is, if you take pi as 22 by 7, so 22 upon 7, this will be 0.2 multiplied by this is 4.4 centimeter per second. If the person is asking this using pi equals 22 by 7. So rest of the answers I've left in terms of pi, but this one can be maybe can be calculated further, and you may get this 4.4 centimeter per second as well, right? This is also sufficient. Okay, that's the answer for us. Anyway, simplification can be done on your own, right? That's not a difficult thing. But this is what we have over here in this question, right? Let's move on to the next one after this. The 7th question says, length x of a rectangle is decreasing at the rate of 5 centimeter per minute. Okay, units of time are minute. And the width y is increasing at the rate of 4 centimeter per minute. When x equals 8 centimeter, y equals 6 centimeter, find the rates of change of perimeter and area of rectangle. There are two parts of the question. Perimeter of rectangle, area of rectangle, both are important. So length x and breadth y. Let's draw the rectangle first. Drawing the diagram, as you may observe, is important. This is x and this is y. Right? X is this length, y is this length over here. Right. Length x of a rectangle is decreasing. Mind you, decreasing is the word which we are using over here. Decreasing implies that as time increases, the length decreases. Therefore, you will have an overall minus sign over there because of the word decreasing. So dx by dt will be minus 5 centimeter per minute. Don't make a mistake over here. This is minus 5 because of that decreasing, right? Remember this. And the width y is increasing at the rate of this. So dy by dt is given to be plus, increasing. Therefore, this is 4 centimeter per minute. What else? When x equals 8 centimeter, y equals 6 centimeter. So length is measured in centimeter, time is measured in minute. We'll have to take care of that in our final answer as well. Find the rate of change of the perimeter and the area of rectangle. Let's talk about the first part. Perimeter of rectangle. What's the perimeter of this rectangle? You remember the formula of perimeter? X plus y plus x plus y. That's the perimeter you measure. This length. This is 2 times x plus y. 2x plus 2y or 2 times bracket में x plus y. And the area of rectangle. Area of rectangle is pretty simple. This is x times y. This is pretty simple, right? So perimeter is 2 times x plus y. Therefore, dp upon what is asked is find the rates of change of the perimeter. So dp upon dt is a question mark, right? In the first part, dp upon dt. We missed out this. This is question mark. In the second part, d area upon dt. This is a question mark, right? This is a question mark. So dp upon dt will be equal to 2 times dx upon dt plus dy upon dt. Therefore, what will be the value of dp upon dt? We'll substitute the values of dx upon dt, which is minus 5 and plus 4. This is minus 1 and 2 will become minus 2. And what's the unit? Unit will be, this is in centimeter, this is in minute, this will be centimeter per minute. Consistent, since units are consistent over here, right? In the given data, there is no inconsistency, right? What about the second part? In the second part, you are supposed to talk about area and find the rate of change of area with respect to time. So we'll have to differentiate this with respect to time. Oh, but x and y both do not depend, are also dependent on time. But what are we supposed to do over here? We are supposed to apply first the product rule and as well as the change rule, right? So dA by dt will be equal to, let's keep x as constant and let's take the derivative of y with respect to time, plus let's keep y constant and let's take the derivative of x with respect to time. This is what we'll do, right? Now let's continue further and see where do these values take us. Therefore dA by dt will be equal to what? X is 8, dy by dt is 4, plus y is 6, dx by dt is minus 5. This is what we have. And therefore, what you'll have is 32 minus 30, which is 2. And the unit will be length square upon time. Length is measured in centimeter, time is measured in minute. So this is centimeter square per minute. That is my answer for the second part over here. This is the answer for the first part, as you can see behind me. Let me get aside so that you can take a look at the solution. And that is all in this question. Let's discuss this question next. The question 8 says a balloon which always remains spherical on inflation. Inflation, are we talking about money? Inflation means increasing its the size. When you blow air into it, the volume of the balloon increases, it inflates. Is being inflated by pumping in 900 cubic centimeters of gas per second. Okay, so volume is increasing at this rate. Okay, this much volume of gas is being pushed in, so the volume will be increasing by so much. Find the rate at which the radius of the balloon increases when the radius is 15 centimeter. Mind you, some of you may argue that, sir, the volume of the gas going inside will actually may be reduced because of the pressure and all, but we are not supposed to consider all of those things. We are not dealing with chemistry over here. In maths, we'll simply assume that this 900 cubic centimeters, the volume of gas wave that we have pushed in, will actually increase the volume by so much only, right? We're not considering any pressure conditions or something of that sort. So keeping that in mind, a balloon which always remains spherical on inflation, spherical shape. Okay, so sphere in 2 dimensions will look like a circle, right? Okay. Inflated by pumping in 900 cubic centimeters of gas per second. So volume is increasing at this rate. Volume of a sphere. Now what is that? This is 4 by 3 pi r power 3. This is what we have, right? Where the radius of this is this, right? So if you are given that dV upon dt, this value, rate of change of volume with respect to time, is 900 cubic centimeters, which is actually centimeter cube per second. This is the unit, right? We have written the units properly to check whether the given data is consistent, right? Find the rate at which the radius of the balloon increases. So dr by dt, radius of the balloon increases, this is question mark, when radius is 15 centimeter. This is being asked, right? Can we deal with this question easily? Yes, it is pretty easy to deal with this question. We are given volume. We have written the formula of volume, 4 by 3 pi r power 3. This is volume. So dV differentiate with respect to time is equal to 4 by 3 pi is okay. R cube, the derivative of R cube will be 3R square, and you have to apply the chain rule. This will be dr over dt since you are differentiating with respect to time. And now you are given this, okay, You're given the radius and you're asked this value from this. Let's rearrange the formula a bit. dr by dt will be equal to what? Will be equal to, you can observe, dv upon dt times this, all of this in the denominator. So 3 will go in the numerator and 4 times 3 is 12 pi r square will come in the denominator. This is what you'll have. Therefore, dr by dt will be equal to what? This will be equal to dv upon dt, which is 900. Okay, units are consistent. Yes, we're not supposed to worry about anything too much. This is 900 times 3 upon 12 pi. What is r? Radius is 15. So this is 15 square is what I have over here. Yes. And do you observe that 15 square is 225 and 225 times 4. 225 times 4 is what equal to? This is equal to 900, right? So 15 square 225 times 4 is 900. 800 for 900. And 4 times 3 is 12 upon 12. This will also get cancelled and what will remain is 1 upon pi. This is what will remain, right? dr by dt is 1 upon pi. The final answer will be centimeter per second in terms of centimeter per second. That is the unit for this question over here, right? Radius is measured in centimeter, time is measured in seconds, so centimeter per second will be the final unit of this. 1 upon pi. If you are asked to find the approximate value of 1 upon pi, what will you do? So you should remember one small thing. What is that? The value of pi square. Pi square is 3.14, right? And pi square is approximately equal to 10. Actually, square root of 10 is something which you can remember. Square root of 10 is 3.16 approximately. So 1 upon pi will be slightly different than that. This will be actually, you can find 1 upon pi, you can multiply by pi square and divide by pi square. Basically, pi square is actually approximately 10, right? This is what we have. So multiplying by pi square and dividing by 10 will give you approximate value, slightly smaller value than the actual thing. So pi upon 10 is 3.14 divided by 10, which is 0.314, but that is slightly smaller than the actual value. So slightly greater value will be 0.31, maybe 5, 6, 7, 8 something, right? This is what you'll have. So you can approximate it up to 2 decimal places and you can write 0.32 maybe, right? That's what you can do, approximate. But that is all approximation. Here we do not need to approximate. But then at some places you may want to, you may have to. So that's the final answer for this question for us over here. Let's move on to the next question after this. The 9th question says a balloon which always remains spherical has a variable radius. Okay, we have a balloon again, yes, and it is spherical balloon, right? This is spherical balloon. Okay, sphere in 2D will look like a circle. Okay, and we are interested in the radius of this balloon. We are interested in the radius of this balloon, which always remains spherical, has a variable radius. The radius varies. Find the rate at which its volume is increasing with the radius. Mind you, the question here is different than the ones that we have been tackling for a while now. Here the person is talking about volume is increasing with the radius. Okay, rate at which volume is increasing with respect to the radius when the when the radius is 10 centimeter. This is being asked when radius is 10 centimeter. The later one, that is radius. So volume, what is the volume of a sphere? This is 4 by 3 pi r power 3. Okay, there is no time involved. We are supposed to find dV upon dr directly, and yes, we can do that. V equals 4 by 3 pi r power 3 and differentiate volume with respect to radius. What is that? What does that give me? 4 by 3 pi. The derivative of r cube is 3r square. And since you are differentiating with respect to r, there is no need of chain rule, right? This is a direct thing. Therefore, dV upon dr that is being asked will be equal to what? That will be equal to 4 by 3 times pi times 3 times 10 square. 3 goes with 3, 10 square is 100. 400 pi is what I'll get. And volume is centimeter cube. This is centimeter. Since the units, the only unit that is given is length, that is centimeter. So this becomes centimeter cube, this becomes centimeter. is centimeter cube per centimeter. That is my answer for this question. 400 pi centimeter cube per centimeter. Is that all? Yes, that's all in this question. Let's move on to the next one after this. The 10th question says a ladder 5 meter long is leaning against a wall. Okay. The bottom of the ladder is pulled along the ground away from the wall. Okay. At the rate 2 centimeter per second. Okay. How fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? Okay. Mind you, now you have to be consistent with your units. So you be careful. Be careful. Length is measured in centimeter over here. Length is measured in meter over here. Length is measured in meter over here. Be consistent. Use either meter or centimeter throughout. That is something which you'll have to take care of, right? So let's try and draw the diagram first of all. What does the diagram say? Let's suppose wall and floor look like this, and they will be perpendicular over here, right? So this is the wall, let's say, and this is the floor, let's say. Right, this is a floor. A ladder 5 meter long is leaning against a wall. Okay, this will be a ladder. Let's represent. From this angle, the ladder would look something like this, maybe. It will be very thin, by the way, but this is something it will look like. And the length of the ladder is 5 meter, it is given. Okay, so this length L over here, L is given as 5 meter. The bottom of the ladder is pulled along the ground away from the wall. Okay, we are interested in this particular point moving away. So moving away from the wall would imply that this particular length, if this is equal to x, so x is increasing, this distance is increasing, this point is moving away, so this x dx by dt is given to be 2 centimeter per second. That's an important observation. If you observe this carefully, you can solve this question easily, right? Next, let's move on to the next statement. Away from the wall at the rate of 2 centimeter per second, x is increasing, so there will be plus. How fast is its height on the wall decreasing? Okay, if you pull this away, the length of the ladder remains same. Obviously, this point will be pulled down. So this distance is important. Next, this distance is important. Let's call this distance y. And what are we asked is dy by dt is equal to question mark. And since this will increase, this will decrease, that is something which we already know. And the person has also asked how fast is this decreasing. Okay, the answer, the value of dy by dt will be minus something. But the person is only interested in that something because he already knows that it will be decreasing. Right? So we are not supposed to mention the final answer in minus whatever, let's say minus 3 or minus 4, whatever. We are supposed to mention only 3 or 4, the magnitude of that. When the foot of the ladder is 4 meter away from the wall, foot of the ladder is 4 meter away, means it is given that x equals 4 meter. This is given to us, right? So let's make the units consistent. For making the units consistent, what we'll have to do? This is 2 centimeter per second, this is 5 meter. Either we convert these meters into centimeters or we convert this centimeter into meter. Now centimeter, 2 centimeter would be actually 0.02 meter, which is also okay. And these lengths 5 and 4 meter are also okay, we can use them as well. But I would like to convert this one. This is 0.02, just a minute. .02 meter per second is what I'll get. Converting everything in terms of every length in terms of meter. This is the rate of change of x, rate of increase of x with respect to time. 0.02 meter per second. Converting the centimeter into meter so that the unit of length throughout is meter only. Final answer will also be obtained in terms of meter. Okay, unit of time is second, that's not a worry for us. Okay, but since dy by dt is asked, do you observe that we'll need some relation between x and y, right? This L is the key, okay, because x any x or any y will have one thing common, that is in this shape, this is a triangular shape, right? In this triangular shape, you'll have this as the hypotenuse, this as the base, and this as the perpendicular. So the important thing to observe over here is x square plus y square will be equal to L square. This is something that you want to observe. Oh, this is a Pythagoras theorem. Yes, this is a Pythagoras theorem. With the help of this, I also know that y will be equal to what? When L is always 5, when x is 4 meter, this particular thing will imply that this is 4, 16, this is not known, this is 5 square, and you can very well guess that these are Pythagorean triplets, 3, 4, 5. This will be 3 square, so therefore this will be 3 meter. That is something which we have found first, right? On the basis of this, we have found this. Is that okay? That's simple, right? So now we have analyzed the question fully, and we only need to do some calculations to get the answer. And what are the calculations that we are looking at? We are looking at some simple calculations. Once again, we need some relation, and yes, we have a formula over here relating these lengths with one another. So x square plus y square is equal to L square. L, mind you, is a constant. L is not changing. X is changing, y is changing, but L is not changing. So let's differentiate this. Differentiate this with respect to time. So what you get is 2x times dx by dt, chain rule, plus 2y times dy by dt, again chain rule. Derivative of L square, L is a constant, so L square is a constant, derivative will be 0 with respect to anything for that matter, right? This is a constant, that's not changing with respect to time. L is not changing with respect to time, so this is 0. Okay, so now we can substitute some values. X is 4 meter, 2 times 4 times dx by dt is 0.02. This is what we have, plus 2 times y, which is 3. We have found that, right? We needed this here. We have already found that. Times dy by dt is equal to 0. This is what we have. Okay, this gives me dy by dt is equal to, let's take all of this on the right hand side, minus 2 times 4 times 0.02 upon, this is 2 times 3 which will come over here, this 2 goes, okay, 4 into 0.02, what is that? 0.08, and this is upon 3, 0.08 over 3 is what I get with the minus. And the units, don't forget the units. The units, this y is measured in meters, right? So this is length and time, this is meter per second, okay? But we can find in terms of centimeter per second. You see, this is 0.02, this was given as 2 centimeters. So let's also find in terms of centimeter. So multiply this by 100, this will give me minus 8 upon 3 centimeter per second is the final value. This. Centimeter per second is the rate of change. But one more thing, the person already mentioned that it is decreasing, so you're not supposed to mention the sign. Sign shows that yes, it was decreasing, and therefore the rate of change of y, that is height, the rate of change of height, write it in this manner, the rate of change of height, or the rate at which the height is decreasing, the rate at which the height is decreasing is, the rate at which the height is decreasing is 8 by 3 centimeter per second. And that is my answer for this one over here. Let's move on to the next question after this. The 11th question says a particle moves along the curve 6y is equal to x cube plus 2. Okay. Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Okay. Now this is not a real life problem. It does not look like a real life problem. But we may encounter such questions, such equations in real life, right? So, okay, that's okay. Let's move on to this. A particle moves along the curve. This is the curve. 6y is equal to x power 3 plus 2. There's no need of any diagram over here, right? Points on the curve. Okay, so you are interested in x comma y points. at which the y coordinate is changing 8 times as fast as the x coordinate, which implies that dy over dx, rate of change of y with respect to x is given to be 8. This is given at x comma y is supposed to be found when dy by dx is equal to 8. This is important. So with the help of this, can I differentiate 6 times dy upon dx? What will that be? This is 3x power 2 plus 0. That's what you'll have, right? Derivative with respect to this. And therefore, 6 times this will be 8 is equal to 3x square, which gives me x square is equal to, this is 16. X square is simply 16, and which gives me x equals 4 or x equals minus 4. Now, what will x equal to 4 give us? The value of y is also required, right? We need the points. Therefore, let's find the value of y. Therefore, y equals x cube plus 2 over 6. This will be equal to 4 cube, which is 64, plus 2 is 66 upon 6, 11. This is 66 upon 6, which is equal to 11. The point will be 4 comma 11. This is the point. What about when x equals minus 4? Therefore, y equals x cube plus 2 over 6. What is that? This is minus 64 plus 2, which is minus 62 upon 6. This is actually equal to minus 31 upon 3. We can cancel the factor of 2, and this will give me further, the point will be minus 4 comma minus 31 by 3. This will be the point over here. So the final answer will have 2 points. 2 points. What are those 2 points? 4 comma 11 and minus 4 comma minus 31 by 3. Don't make a mistake in this. Don't miss out the other point, right? X equals 4 or x equals minus 4 is what you're getting with this equation, right? That's a complete solution of this question, as you can see over here. Let's move on to the next one after this. The next question, 12th, says radius of an air bubble is increasing at the rate of half centimeter per second. Okay. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? So bubble, what is the shape of a bubble? Air bubble is spherical, right? Air bubble is spherical, will look like this in 2 dimensions, right? Radius of an air bubble, let's talk about the radius. This is r, is increasing at the rate of half centimeter per second. dr by dt is equal to 1 by 2 centimeter per second. At what rate is the volume of the bubble increasing? So dV by dt is equal to question mark. When the radius is 1 centimeter, r equals 1 centimeter, at r equals 1 centimeter. So what is the volume of this bubble? This is 4 by 3 pi r power 3. Okay. Use this information with that formula and you have your solution very easily. We need dV by dt. Let's differentiate with respect to time. This is 4 by 3 pi 3r square dr by dt. That's the derivative of r power 3. We have to apply chain rule since we are differentiating with respect to time. Right. And dV by dt is what we are looking forward to. So therefore dV over dt is 4 by 3 pi times 3 r square. Now what is r? This is 1 square. What is dr by dt? This is half. And units, as you may observe, length is always in centimeters. So time is in seconds. So the units are consistent, right? We're not supposed to worry too much about anything over here. This 3 goes with this 3. This 2 cancels this 4 and we get a 2. You get 2 pi, 1 square is simply 1. 2 pi, final unit will be, this is length cube, that is meter cube per second. Centimeter cube, mind you, not meter. This is centimeter cube per second. That's your answer. Final answer for this question. This is the rate of change of volume. This is the increase of volume. 2 pi centimeter cube per second. Let's move on to the next question after this. The 13th question says a balloon which always remains spherical. Okay, we are talking about a balloon has a variable diameter. This. Now we are talking about the diameter over here. Let's not forget that. And this is the diameter, let's say. And if this is the diameter, then this will be the radius, which is half of diameter, right? Variable diameter this. Find the rate of its volume with respect to x. Rate of change of its volume with respect to x, okay. A balloon which is always spherical has a variable diameter. So diameter is equal to 3 by 2, 2x plus 1. Diameter is dependent upon this x. This x is some independent variable, right? We're not sure what that will be. This is some independent variable. Okay. So can you observe that therefore radius will be equal to what? This will be d by 2, which gives me radius will be equal to 3 by 4 times 2x plus 1. Okay. What next? Find the rate of change of its volume with respect to x. This is being asked. This is being asked. And what is the volume of this? Pi r power 3. This is the volume of a spherical balloon. Let's use this. V equals 4 by 3 pi r power 3. So dV upon dx, that is being asked, will be equal to 4 by 3 pi. The derivative of r cube with respect to x is what you are interested in. This will be 3r square, and on applying chain rule, dr by dx is what I'll get. And do you observe that dr by dx is something that you already know from the given information? Yes. Using this r, we can find dr by dx very easily, right? Yes. So let's find that dr by dx. dr by dx is equal to what? 3 by 4 is okay. This is derivative of 2x is simply 2. So this is 3 by 2 actually. This is 3 by 2. Okay. There are no units mentioned. Well, there's no need to worry about units. The person has also not mentioned any unit. With respect to x, there's no unit, right? So we'll also leave the answer in terms of x and let the units take care of themselves. So 3 goes with 3. Therefore, dv upon dx will be equal to 4 pi. What is r? R is this. 3 by 4 times 2x plus 1 whole square, and dr by dx is 3 by 2. What is that? Leave us with. This is 4 pi times, this is 9 upon 16, 2x plus 1 whole square times 3 by 2. Okay, this is 4, and 9 times 3 is 27 by 8 pi times 2x plus 1 whole square is what I get, and that is my answer for this question. If you observe, you can also guess the unit of x, and on the basis of that you can comment, right? So this is diameter, variable diameter. Diameter will have similar units as x, right? This x has similar units, maybe, right? That's what you can observe, or something else. But the units of x, if they are in meters, let's say. So r will be in meter, and in this case, this is meter square. It is actually meter cube per meter. It is actually meter cube per meter, but this is finally, after cancelling out the meters, this will be meter square. But this is actually meter cube per meter over here. That's what you can observe, right? This is the final answer for this question, as you can clearly see behind me. That's all in this question. Let's move on to the next one. The 14th question says, sand is pouring from a pipe at the rate of 12 centimeter cube per second. Okay, from a pipe. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. Okay, radius of the base is important, height is important, there's some relation between them. How fast is the height of the sand cone increasing when the height is 4 centimeter? We're interested in these things. Let's talk about the diagram first. So on the ground, you'll be having a conical sand pile. This is the conical. This looks like some kind of cone. This is the ground. Okay, this is the ground. And the cone from the side angle will look like this. You can draw a circular over here. Yes, you can draw a circular over here, but this is the radius of the cone. I can mark the radius in this manner. And this here will be the height of the cone. This is the height of the cone. Sand is pouring over here. Sand is pouring from a pipe. right? Sand is pouring and we are getting a cone formation. There's some relation given, right? This is a shape and then there's some data given. Let's note the data. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. This is basically the volume of the cone will be increasing by that rate, right? Sand is forming the cone, so volume of the cone is increasing at that rate. dV upon dt is given to be 12 centimeter cube per second. It also says centimeter cube. This is volume, right? What is the volume of this cube, by the way? Do you remember the volume? Yes. This is 1 by 3 pi r square h. This is the formula for volume. 1 by 3 pi r square h. Okay. The falling sand forms a cone on the ground in such a way, height of the cone is always 1/6 of the radius. Height is 1 by 6 of the radius. This is also given, right? That's another relation given over here. Okay, what else? How fast is the height of the sand cone increasing? dH over dt is being asked. Okay, when the height is 4 centimeter. This is being asked. Height is 4 centimeter. When height is 4 centimeter, what will be the radius? Radius will be 6h, which gives me at this particular point, radius will be 24 centimeter. This is what you have, right? Next, we are dealing with the volume, right? It is given this, and we are asked this with the help of maybe R and H, the values of R and H. So let's use this V equals 1 by 3 pi R square H. Do you observe that dH by dt is what we are supposed to find? There should not be any R remaining in this formula before you differentiate. So let's eliminate R with the help of this result. R equals 6h, right? So this gives me V equals 1 by 3 pi R square becomes 6h square times h. And what is this? 1 by 3 pi is okay. This is 36. H square times h is h power 3. This becomes 12 pi h power 3. This becomes 12 pi h power 3. 36 upon 3 is 12. There is a pi and there is h power 3. This is V. Okay. Next, let us differentiate this volume with respect to T. Volume with respect to T. Therefore, dV by dt is equal to, this gives me dV by dt is equal to 12 pi times 3h square dH by dt. Oh, we don't need this one actually. We only need h. Okay. And we can find dH by dt very easily. Therefore, let's substitute the values. This is 12. Consistency of units has to be meted out. This is length is in centimeter, length is in centimeter. Those are the only units given. Time is in seconds. So 12 will be equal to 12 pi times 3h square, which is 4 square times dH by dt. This 12 goes with this 12. This implies dH upon dt is equal to 1 upon pi will go over there. 3 times, this is 16. 16 times 3 is 48. This becomes 48 pi. Is that all? Yes. This is 1 upon 48 pi. And h is in centimeter. This is in seconds. So the answer will be centimeter per second. This is the final answer for this question over here. Let's move on to the next one after this. The next question says 15th. The total cost Cx in rupees associated with the production of X units of an item is given by this. Okay, cost with respect to item produced is this. Find the marginal cost when 17 units are produced. Okay. Marginal cost will be the rate of change of cost with respect to X. That is what we are interested in, right? Total cost in rupees, it is already given Cx is equal to 0.007 x power 3 minus 0.003 x power 2 plus 15x plus 4000 is what I have, right? This is what I have. Find the marginal cost. So we are interested in dCx over 17 units are produced over dx is equal to question mark when x equals 17. This is what we are interested in, right? Let's talk about this. Derivative can be found very easily with the help of simple differentiation. Is equal to what? This is 0.0073x power 2. Okay, with respect to x, this is it. Minus 0.0032x plus 15. This is what I have, right? Derivative of x will be 1. This is 0. And when x equals 17, can I find the value? Yes. Therefore, dCx over Cx over dx when x equals 17 will be equal to what? Let's substitute x equals to 17 over here. 0.007 times 3 and times 17 square, which is 289, minus 0.003 times 2 into 17, which is 34, and plus 15 is what I'll be getting. This is what I'll be getting, right? What else? This becomes 21 times 289 is what I'm interested in, and divided by 1000 because this is 0.007. So 21 times 289, can we multiply them together? Yes. 21 times 9, what is that? This is 189, so you'll have a 9 and 18 gets carried forward. 21 times 8 is, what you'll get is, 21 times 8 will give me 168 plus 18. 168 plus 18, 178, 186. So you get 6 and 18 carried forward again. 21 times 2 is 42 and you got a 18, so you get 60 over here. This is 6069 and decimal after 3 places from the end. This is what you get. What about this? 3 times 34 is pretty simple. This is 90, this is 102 actually, and this will become 102 and this will be 0.102 with a minus, plus 15 is what remains. Let's subtract these two. This becomes 6.069, 9 minus 2 is, okay, this is 7, 6 minus 0 is 6 and 60 minus 1 is 59. This is 5.967 plus 15, what does that give me? This is 20.967, which approximately is equal to, since there are 3 significant figures involved, in the final answer we can leave by round off the last one. This is 20.97. This is dCx upon dx. That's the marginal cost in rupees associated with the production of x units. So rupees per unit is the final unit that will have. Rupees per unit. This is the final unit of this question over here. That's the final answer, as you can see behind me, for this question. Let's move on to the next one after this. The 16th question says the total revenue in rupees received from the sale of x units of a product. Received from x units of a product is given by Rx equals 13x square plus 26x plus 15. Find the marginal revenue when x equals 17. Now here Rx is given and we are asked marginal revenue when x equals 7. That simply implies that you are supposed to find dr upon dx. Yes. Let's try to find that somehow. Total revenue in rupees received from the sale of x units of a product is this 13x square plus 26x plus 15. Okay. And you are asked drx upon dx is equal to question mark when x equals 7. When x equals 7, this is being asked, right? And how do we find that? We simply differentiate this r with respect to x. So drx with respect to x will be equal to what? This is 26x plus 26 is what I get, right? This is what I get. And therefore drx upon dx at x equals 7 will be equal to 26x, or you can say that the value of x has been substituted now to be 7. 26 times 7 plus 26. You can take out a 26 common and what do you get is 7 plus 1, 8. Let's find 26 times 8. What is that? 8 times 6 is 48, 4, 2 is 16, and this will become 208 is what I get. 26 times 8 is this, 208, and unit of R is rupees, and this is unit. So this is rupees per unit is what I get. This is the final answer. 208 rupees per unit is the marginal revenue. That's what you have. This is what you have. Is that okay? Yes. Let's continue further and move on to the next question. 17th question is an objective one, and what does it say? The rate of change of the area of a circle with respect to its radius r at r equal to 6 centimeter is a pretty simple one for that matter. You've dealt with circles and we are dealing with area of circle with respect to the radius. This is radius and area will be pi r square. Okay. Rate of change of area of a circle is being asked, dA by d with respect to its radius. Okay, dA by dr is being asked. When r equals 6 centimeters, what we are interested in. Okay, can we find this? Yes. Area is pi r square. So dA over dr will be pi times 2r. Okay, that's pretty simple differentiation, yes. And when r equals 6 centimeter, therefore dA by dr will be equal to pi times 2 times 6. This is 12 pi centimeter square per centimeter is what I get. Right? Units are measured in centimeter. And which option is correct with respect to its radius r at r equal to 6 centimeter? You are only supposed to find the magnitude since units are not mentioned. You are not supposed to worry about that too much. 12 pi is the answer. Therefore, this option B is the correct answer for this question over here. That's all? Yes. Let's move on to the next one. The 18th question is an objective one, and the question says that the total revenue in rupees received from the sale of X units of a product is given by Rx equals this, the marginal revenue when X equals to 15. So we are interested in dRx. Rx is given, derivative with respect to X is what we are interested in. When X equals 15. Okay. So given the value of Rx equals 3x square plus 36x plus 5. Can you find d of Rx over d of x is equal to, this is what is equal to, this 6x plus 36 is what I am getting. And when x equals 15, therefore d Rx over dx is equal to what? 6 times 15 plus 36. Now this is 90. This is plus over here. Yes. So this is 90 plus 36. What is that? This is 126. And the units, you can also mention the unit. Revenue is in rupees. This is in units. So this is rupees per unit. That's what we have. And the answer over here, you can see that the correct answer will be option D. Not supposed to worry about the units. The answer will be 126 rupees per unit, or simply option D, as you can see with this question. Right? That's all that you have in this question. And with this, we come to the conclusion of this exercise 6.1 from the chapter Application of Derivatives, Mathematics Class 12th. In the next video, we'll be talking about another exercise. Till then, all the best.